This is lesson 11.6, and this is Cramer right there. Not Cramer from Seinfeld, but Cramer from math. And so we're learning about determinants and something called Cramer's rule, which is a way of solving a system. So we're finally going to use, well, in this case, determinants, which are kind of like matrices. So if I wanted to find the determinant of a 2 by 2 matrix, there is a formula. So you might see this written as find the determinant of matrix A. That's how a calculator would write it. DET means determinant in the calculator. Sometimes we'll use this notation. We'll actually, it kind of looks like a matrix, but it doesn't have the bracket parts of the matrix. And so that means find the determinant, or I might just say find the determinant of this matrix. And so if you do, the formula is AD, you take that matrix, go diagonally, AD minus BC. So you go diagonally the other way. So kind of start top left to bottom right, and then go the other way here to do that. Okay, so let's try to do this one by hand. So this will be 3 times 4, which is 12, minus 5 times 2, which is 10, which is 2. This isn't bad, right? Find the determinant of this one. This would be 2 times 1 is 2, minus, be careful, that's actually a negative 4. So I'm subtracting a negative 4, which is like boom, boom, plus a positive, so this is 6. Okay, see if this one's, again, pretty similar to that one. Negative 5 minus, whatever that is, which is negative 6. So that's going to add a positive there, so that'd be 1 is the determinant. And before we go into this one, let's actually type this in our calculator. So to get that in your calculator, so you can hit the menu key and you see number 7 is matrix and vector. So we go to that one and you see the third choice is determinant. So then you can put a 2 by 2 matrix inside of that determinant. So it'd be negative 5, negative 2, 3, and 1. And the determinant is 1, right? It's just got what we need there. Determinant of this one. Oof. So you can really, this is, let's see, this would be a 3 by 2 matrix. So you can only find the determinant of square matrices. So that's kind of a thing. Wow, this is weird. I guess technically this is a 1 by 1 matrix. So I think the calculator could find the determinant of this. I don't know if I've done this before. So let's just go there and go to determinant. Let's put a 1 by 1 in. So I'm going to put customizable matrix 1 by 1. 5 goes in there, and the determinant is, well, that's interesting. So if it's just one number in there, which I will never ask you that question, you would just, it would be whatever that one number is. Okay, so if the matrix is bigger than a 2 by 2, and I'll have some of these, you'll see, I'll say, okay, do this one by hand, or I'll say, do this one on the calculator. I'll specify. There'll be times where I'll let you do this on the calculator. Times where I say, you got to show the work and do this by hand. So there are different methods for this. Your book may even lay out a different method than this. My favorite is the diagonals method. So after doing this a few times, I just really like this method. So the diagonals method is where you, the first thing you do for the diagonals method is you kind of, sounds weird to say, I'm going to try to write it out. So you want to like copy the first two columns of data to the right. So immediately to the right of the matrix. So you see that 2, 0, negative 2. So I'm going to put 2, 0, and negative 2. I'm copying it. And the next column, 3, 2, 5. So 3, 2, 5. I'm just kind of extending the pattern. If this matrix is kind of repeated or something, I'm extending the pattern. So then the second step is to draw diagonals. First this way. So from top left. So I'm going to do that here. So I'm going to do this diagonal, and I draw my three diagonals because it'll every time it'll be three diagonals, and you basically multiply. So we're going to add. We're going to go there. So 2 times 2 times 6 is 4 times 6 is 24. So I get 24 plus 3 times 4 is 12 times negative 2 is negative 24. Wow. Okay. Plus negative 1 times 0 times 5. 0 times anything is 0. So I get 0. So the sum of that one, of those three, are actually 0. Okay. So now we kind of multiply and add, I guess, is that step. We multiply and add. Step 4, you're going to do diagonals the other way. So this one is bottom left to upwards. So I'm going to go, okay, from here to there, here to here, and from here to here. Right, so let's multiply and add those as well. So negative 2 times 2 is negative 4, times negative 1 is positive 4, plus 5 times 4 is 20, times 2 is 40. Okay, now we're getting somewhere. That's a bigger number. And 6 times 0 times 3 is plus 0. So we get 44. And very similar to the way, if you look back, the thing I like about this, if you know the pattern of, let's go back to that formula. Like, think about the pattern of this. It's AD, so it's diagonally from top left to bottom, AD minus BC. So it's top left to bottom right, AD minus BC. So that same pattern kind of applies here. So we want to go diagonally this way, which is this number. So it's going to be 0 minus, then diagonally that way, which is the 44. So if you memorize that other pattern, this one is very similar. So we should get, I hope, negative 44. So let's see if we did this right. It's been a while since I've done this, so let's just see what this looks like. So we go menu, matrix and vector. We're going to go to determinant, and we're going to put a 3 by 3 in there. So I'm going to go to 3 by 3. That defaults to that. So 2, 3, negative 1, 0, 2, 4, negative 2, 5, and 6. So negative 44 is in fact the determinant, which is what we got by hand. So that's good. It's easy to make a mistake in this kind of thing, but again, if you memorize the formula for the other one, certainly helps a ton in this one. So let's try the method. Again, first step, you want to kind of just copy the first two columns, 2, 0, 0, 0, 6, 3. I try to do it about the same distance, I guess, when I do it. Okay, so we're doing this. We're going diagonally this way and writing our answer down here. So it's 2 times 6 is 12 times negative 5 is, I believe, negative 60. This one is going to be, well, 0. So plus 0. And this one, wow, when there's zeros in there, it just makes everything easier to do. So we get negative 60. Okay. We're going to go the other way. So we get 0 plus 12 times 2 is 24. Okay, 24 and plus 0. So according to the pattern we learned before, AD, so it'd be negative 60 minus that total, which is 24. So that's negative 84 is the determinant. And we're going to use this kind of thing. So don't think, well, why are we getting the determinant? We're going to use it in just a second here. Let's try one more. So just make sure you're getting it. I think you are getting it, though. So I'm going kind of fast here. 3, 2, 5. Multiply those. 4 times 6 is 24. 12 times 2 is negative 24. Okay. And 0. So I get 0. Did we do this one? Looks familiar. So it would be 4. 20 times 2 is 40. Is that the same problem? 201. A little different. 2, 3, negative 1. 0, 2, 4. That's the same problem we did a minute ago. Okay. Don't worry about that one. Okay. Cramer's rule. So Cramer's rule is a little bit different. So we're going to use determinants That's why we had to learn about determinants first to do Cramer's rule. So Cramer's rule is going to solve a system like this by using Cramer's rule. So this is kind of how Cramer's rule works. They're going to say x equals, it's just a big fraction. In the numerator is going to be a determinant. In the denominator is going to be a determinant. So what you do in the denominator, start with the denominator, you take the coefficients of all the coefficients there, right? So you get 1, 2, 2, and that coefficient is technically a 1 there. So 1, 2, 2, 1. Now the weird thing about this is up top, do you see how those x's are on the left? And this is x. So I'm going to replace the x's with, so I'm going to, like on the top, it's going to be 2 and 1, whatever the coefficient matrices were. But I'm replacing just those values with the constants here. So this is going to be 8 and 10. That's the unusual part. So the top and bottom matrices will be exactly the same, except for whatever variable you're solving for. Right now, x is on the left, so that's the one we're substituting the constants for. So we're going to do the matrix, we're going to evaluate this and see what you get. So 8 times 1 is 8. These are determinants. Minus 2 times 10 is 20. So in my numerator, I get negative 14. Denominator, I get 1 minus 4, which is negative 3. So I think I get 14 thirds. Wow, that's fun. Okay, so y is also a big fraction. In the denominator, it's the same numbers. It's the coefficient. I'm just going to put, I'm not even going to write it. It's just negative 3, right? We simplified that. We've got it. In the numerator, it's the same as the denominator. 1, 2, 2, 1. But instead of, we're going to erase these two because now the y values are on the right up there. So I'm going to erase those two. I'm going to replace them with this 8 and 10. So 8 and 10 replace those y value points. So I'm kind of highlighting the ones I'm replacing. Again, the denominator is just the coefficient matrix. I already evaluated it. It's negative 3, so like, why do that again? Trying to save work when we can. So 1 times 10 is 10, minus 2 times 8 is 16. So we get negative 6 over negative 3, which is 2. So we get 2 and 14 thirds. And so that should work if we plug that in. By the way, in case you didn't know this, 8 minus 20 is negative 12, which means this is 12 over 3, which means x is 4. I was wondering about that. I thought, so my answer is actually 4, comma 2. I always put x comma y in ordered pairs for this chapter. And sometimes you got to check your work. And I'm like, that seemed a little funny. I was trying to check it if I plug it in, right? You should be able to plug this in. 2 times 4 is 8. Plus 2 is 10. That works. 4 plus 2 times 2 is 4. 4 plus 4 is 8. It works in both equations. This definitely works. Right? It's just a different way of getting it. And you might say, well, why do I do that? Because it can be easier, especially as the matrices get bigger. But let's try this one. So that's the same problem, actually. So we're going to work just this one. Okay, so x equals, in the denominator is the coefficient matrix, 2, 1, 6, and 8. In the numerator is the coefficient matrix, except because I'm solving for x, I'm going to erase these two guys. And when I put in there, because x is on the left, my constant matrix, so negative 1 and 2. So now I'm just going to evaluate this. So it's going to be negative 8. Let's determine that one, minus 12, which is, this should be negative 20. In the denominator, it'd be 16 minus 6, which is 10, which is negative 2. Okay. Y equals, my denominator, I already know it's 10, so I'm not going to redo it. My numerator is the same coefficients of 2, 1, 6, and 8. But because y's are on the right here, we're going to erase those, and we're going to plug in the coefficient matrix, negative 1, or the constant matrix there. So we get 4 minus -1, which is 5 over 10, which is 1/2. And so we get an answer of -2, comma, 1/2 for my x and y. Okay, here we go. So let's try this. It works also with this. So this one's going to be interesting because in the denominator, if I do the coefficients, I get 2, -3, and 4. That's easy. This one's 1, so 1. I guess it's 0 and 6. 3, whoops, 3, -2, and 0. So there are a couple zeros in there. I'm going to repeat that same thing up here. -3, 0, -2, 4, 6, 0. And then instead of this, I'm going to put in the constant matrix. So it'll be 1, 0, and 5. Since I'm solving for x. If I was doing y, I would replace the middle column. If I was doing z, I would replace the right-hand column. So I get. So now you'd have to do the diagonals method or something here. So when you're doing a 3 by 3 with Cramer's rule, what I'm going to let you do, I'm going to let you use your calculator. So don't do this all at once. It's much easier to do each determinant. You won't make as many mistakes if you do this as the separate numerator and separate denominator. I've seen students make tons of mistake on this when they try to type it in as one big fraction. It's kind of a recipe for disaster here. So don't do that. Okay, so we're going to do this separately. I also like to get the separate answer here. So this is 2, -3, 4, 1, 0, 6, and 3, -2, and 0. So the denominator is -38. I like that because now when I do my y value, it's -38 is my denominator, right? I already know it, same denominator. This one is, well, let's work it out here. So, by the way, you can just type the letters DET if you want. That also works, and put a parentheses. It's a 3 by 3. So 1, 3, 4, 0, 0, 6, 5, -2, 0. -78. See, does that simplify? So, so -78 divided by -38. Okay, that is definitely positive now. 39 over 18. This is a good one to use a calculator on. Like this would be a lot of work to do this. Not with a calculator here. You have to do the diagonals method a couple times. So 2, 1, 3 is that first column of the coefficient matrix. 4, 6, 0 is the third column. And the middle column I'm going to replace with the constant values, which are 1, 0, and 5. That's a 0 there. Okay, so let's type this in. So determinant of 3 by 3, 2, 1, 4, 1, 0, 6, and 3, 5, 0. So -22. So this one ends up being -22 divided by -38. So let's see, whoops. So -22 divided by -38 is 11/19. And finally, we'll do the last one. So same coefficient matrix here. By the way, the denominator is definitely going to be -38. Don't have to redo it. It's the same for all three. So 2, 1, 3, -3, 0, -2. And then I'm going to replace the z values with my constant, which is 1, 0, and 5. Okay, so let's type that in. determinant of 3 by 3, 2, -3, 1, 1, 0, 0, 3, -2, 5. So this is 13 over -38. I don't think that really simplifies there, so that's a prime number up there. So my final answer is, I guess it'd be 39/18 comma 11/19. Wow, what a bizarre answer. And 13 over -13 over 38. That's it. So you see, these are good for, well, I mean, that'd be kind of a pain to solve that one by hand. That's not an easy thing. So the bigger the system is, the easier Cramer's rule is to do. Because the calculator can handle these as you get bigger and bigger and bigger. So I think y'all are getting it. So we're going to stop the lesson there. Thanks.